Hello and welcome to Group 22629's project video, Intelligent Access Point System. On our team, we have Dylan, Margaret, and Sam on electrical engineering, Kelly and Megan on mechanical engineering, and Kenzo on computer engineering. Our client was the Rochester Makerspace. RMS is a nonprofit, member-driven workshop designed for makers of all skill levels. They were interested in a universal and cost-efficient solution that makes their space safer by restricting unqualified access to high-powered machines and standardizing their e-stops. We delivered a single prototype of an access control system that can handle 120 to 480 volts and up to 40 amps. This system can be installed on any of the machines in the makerspace and has a standardized front-mounted e-stop.
Our first working prototypes were on a pegboard to demonstrate the electrical and software capabilities of the device and to adjust and test the device before affixing it to a box. Multiple tests on the electrical system were performed throughout the project. Node voltage tests show that the e-stop was functional. Latency tests revealed an average cutoff time of 6.88 milliseconds. The contactor terminal test verified the functioning of the contactor, and other parts tests, such as establishing the wires were soldered correctly by checking that a wire was a short, also made sure components worked.
There were many changes to the box specifications throughout the project due to updating electrical designs and new knowledge of electrical codes that we had to consider. To verify that the interior of our final high voltage box would operate within the allowable operating temperature of 70 degrees Celsius, we conducted a test where a thermal probe was attached to the heatsink and the system was run for an hour. The results showed that we were well within the safe bounds of the components. Our final product is a two-box system, one 12 by 12 by 8-inch steel box and one 6 by 4 by 3 polycarbonate box for high and low voltage electronics respectively. The low voltage box is user-facing, containing the RFID scanner, e-stop, and LEDs.
The overall electrical schematic shows power coming in goes to the AC-DC converter and the contactor. 5 volts is provided to the e-stop, and the microcontroller, which reads in voltage from the e-stop, connects to the RFID reader, controls the LEDs, and can control the contactor coil. The e-stop also shuts off power to the machine by controlling the contactor coil.
The diagram on the left here shows an informal wiring diagram of the embedded electronics. On the right is a diagram of the state machines implemented in the firmware. This diagram shows the various states communicated to the user through the LEDs. This chart shows the final bill of materials for our project. The top is the cost for the pair of boxes at each machine. The bottom is the cost of the Pi 5 computer used as a central server. Finally, we would like to acknowledge and express gratitude to our contacts at Rochester Makerspace, our MSD guides, and RIT faculty and staff, without whom this project would not have been possible.